Okay, in this video, I'm going to take a look at some of the very specific things dealing with strings. When you store a string in memory, uh, how much space is it using up? Am I keeping track of the end of string character? And what I want to avoid is writing a string to memory and then writing over top of some other area that I'm using for memory, which causes some errors. If that string writes over top of the MI location that I'm using for an addition operation, I could get some crazy errors that are hard to follow. So I want to look at the specifics of strings and, in more general terms, how to experiment with instructions and make sure that you have all the details correct so that you're not causing yourself problems when you write a program. So if you're going to follow along, what you need is the VisiLogic software, and I'm using a Unitronics 350. You don't specifically have to use that model, but that will work for what's there. And I have an example program. That's what you see up on the screen. So my focus is going to be when an instruction executes, and it does vectors or strings, and it writes them in memory, I want to take a good look at what actually is written into memory when that program executes. And I'll probably be focusing on that end of string character. Is it included or isn't it included? And what we're going to do is try and get the exact amount of memory allocated or set aside so that we don't write over top of something else that we don't want to until we're done. So the first thing I do is set up some vector fills in these programs that are here. I think there's like 3 or 4 different sections here to look at different instructions. But I set up vector fills to fill areas of memory just a little bit bigger than I think I might be using with a character, so that when I do my string operations or my instructions and I write to memory, I can see what's affected. So that's what you see up on the screen right here, a vector fill for the first little area that we want to talk about. And that fills in hex 78, which is ASCII character for a lowercase x. So we're going to fill our memory with lowercase x's first. We're going to execute our instruction and see what's affected. So you can see this vector fill here, and I'm going to initiate that on a just within the program while it's running, and force that location high then low again, so that this vector fill occurs. You'll notice in this program I'm staying away from the HMI interface. The HMI interface does some of its own formatting and working with characters. I'll hit that up later, but I don't want that variable in here. I just want to be working with the program. I don't want the HMI to do any of the formatting or working with the end of string characters. I want to see it specifically, and I don't want anything else affecting that. So I got my vector fill. In this case, you can see that we're putting 7878, which is, 2 8-bit ASCII characters into one MI location. We can pack them in there, and that's what we're going to do. So MI locations can hold 2 8-bit ASCII characters, and ML locations can hold 4. So in this case, our string MI2 with length of 4. So MI2, if I go down here to my operands, MI2 through 4 locations, 2, 3, 4, 5, I'm going to put all X's in there when the program's up and running. And I'm doing that in preparation for the execution of this next instruction, and it's the number to ASCII 2 instruction. So a little bit of explanation first. When I hear the word ASCII 2, that means to me I'm getting 8-bit ASCII characters. Probably really 7 bits is more correct to say, but we have an 8-bit storage container, so we'll say 8-bit ASCII 2 values. And what the purpose of this is to take a number And instead of the number being a binary representation of that number, it's going to convert it to the ASCII 2 characters that represent it. So if I have 356, this instruction is going to change 3 of 300 to the ASCII value for 3, 5, ASCII value for 5, ASCII value for 6, and store it into memory. The purpose for doing that is usually if you want to transmit numbers across some kind of communications link, say it's an RS-232 link, and they use X on X off characters to start and stop the transmission when they run into buffering problems. If I send true numbers, binary representations, there's a chance that I'll get those X on X off characters by accident within the numbers themselves. So what we do is change it to ASCII, and X on X off isn't a normal printable character that we send, and that solves that problem. So number to ASCII instruction has a number of parameters to deal with. The help file, usually probably the go-to place. If I go to the help file, go for help, I move that within the window here. Let me resize just a little bit so we catch everything without air. And I come down to ladder instructions, and I look at string functions, and I find the number to ASCII, and I bring this down. It talks about all the operands in here. You have to tell it where the starting address is for the value that you want, the length in bytes, select the format that you want it to have, and all that. So you can look in the help file and see that. So we have this up here. We have a number that we can change. We have no fancy HMI interface, so we'll just change this while the program runs, and we can put different numbers in here and get a resolving ASCII to string from the conversion from the instruction. Next thing that I have to do is tell it the length, and that is the length in characters that we want to store the resolving string. So we're going to have to know our formatting a little bit when we do that to know how many string locations I have to, ASCII character locations I have to allocate in memory. This little one I'll double click on here. This constant shows me all the different formats that I can pick to do that. So I have picked, when it does the conversion, I want to see a decimal number, and I want to show a plus or minus sign no matter what. There's some other options here. Only show the negative sign, do hex, do binary float. That's going to affect how many characters you have to leave for your resolving string. Also, too, there's another constant here that helps with the formatting of how it appears when it's changed to ASCII. And you can see, you can have no leading zeros, you can have spaces, you can have zeros themselves. I chose zeros so that it'll show up. So if we do a number like 12, it's going to do plus 00012. Also, finally down here, you can choose the decimal place, how many decimal places you want. Don't want any here. I'm just going to deal with an integer value, and I don't want to put any decimal places in here. So when I hit this conversion button, we're going to take a number that we have in here, and based on these formatting options here, it's going to give us a string. I've set aside the MI2 area, and just to make sure, it says here that I'm going to put that result in 6 character spaces, which takes 3 MI locations when I pack my ASCII 2 characters in there. But I set aside one more just in case it writes something that I don't expect. That's exactly why I'm, reviewing this and going over it. So I got this all set up and ready to go. I'm going to download this to my PLC, and once it's downloaded, I'm going to run this. No HMI interface, because as I said, I don't want the HMI formatting to mess with it. I just want to see the raw values. So when I run this program, I've set up some memory locations to show the ASCII to contents also in a little bit better format. Now, right now what you see here is the result of me running this program before. So if I go up here and I want to force this vector fill, I hit the set and reset. You'll notice that all X's went into that MI2 location. That's me setting it up so I can see what's written there. If you want to look at the operands and MI2 over here, you can see 7878 going in each of those locations to put the X there. That's not the purpose of my program. That's so I can view to see what happens. So when I come down here to the number to ASCII conversion, that's what I'm going to do, what I want. So I'm going to put the number 12 in here, and I'm going to send that. I didn't hit the button to do the execution. I'm just setting up to do that. Notice that 12 is an integer, and it's going to be converted to a string. I told it to show the decimal sign, so I should see a plus sign at the beginning of that string. I told it to show leading zeros, so it should fill zeros into all the other locations where it doesn't, like 112 only takes 2 locations, and I did 6 together, so the plus sign and the 112 are going to take up 3, so I should get 3 leading zeros on there. And I said no decimal places when I did that. So I'm going to go back to the memory tab down here. I'm going to go and make this happen. And when I make that happen, and I'm going to set that back to there, you'll see that the resulting string has done exactly what I said. So we said 6 characters, the plus sign is 1, 3 zeros is 4, 5, 6. Notice the 2 X's just are left over for me doing the memory fill. So I know I don't write any more than 00012, and that converts that number to from a integer to a string. And just to make sure that we'll put another number in there, minus 345, and I'll send that, and I'll make this happen again. And you can see that in the resulting string is minus 345 and 2 X's. The one thing that really is I'm zeroing in on here is the fact that it did a number to ASCII 2, which I thought would be a string. And a string has to have a length and a terminating character, a 00 or a null or end of string, whatever you want to call it. It's funny that this function does the ASCII 2 conversions and gives me all the digits, but you'll notice it doesn't store the end of string character, which is a little confusing to me. Expected probably to see that. I also increased this number of ASCII characters in the result to 7, thinking that maybe I just didn't give it enough space based on the formatting that I chose to do that. And when I increased it to 7, I just ended up with another 0 in the number, and this other X went away, but it still did not write the end of string character. So that's one of that's actually the detail that I wanted to dial down into to see if it actually, when it did the number to ASCII conversion, if it could create a string. And really what it did was create a sequence of ASCII characters that represent the number. And we're going to stop there. I have some more parts to this video. Things are getting a little bit long, but we'll stop there and have this the first in a series of string details, but specific instructions, in this case the number to ASCII instruction, to see how it ended up with the string. Stay tuned for more.